Hi, in this video I'll talk about the basic concept of motion in a plane and equations of motion. You can see a green box that's moving on a horizontal checkered surface. That surface is absolutely flat, and this is what we mean by motion in a plane. Now, to get to the equations of motion, there are 5 things that we have to keep in mind: the initial velocity, the final velocity, the acceleration, the time taken from start to finish, and the displacement of the box from beginning to the end. So let's look at an animation from the side view. So you can see a clear start point, the yellow line on the left, and a clear finish point, the yellow line on the right. In any equation of motion, we must be clear about the start and the finish point. The rest will become easier. So you can see the box that's moving from that start point to the finish point. If v and u are the same, it means there is no acceleration. If the final velocity is different from the initial velocity, there must either be an acceleration or a deceleration. The displacement is clearly shown as arrows from start to finish, and the time duration from start to finish is also shown very clearly. In other words, if we look at this still image, there are 5 things that we must be clear in any equation of motion, and most of the numericals involve finding the unknowns and considering 3 or 4 knowns. There are only 3 equations of motion which we must know by heart. The first one is v is equal to u plus at, where you can see that there are 4 things there: v, u, a, and t. Now, out of these 4 things, if the numerical gives us any 3, we can find the 4th. For example, if we know v, u, and a, we can find t. If we know v, a, and t, we can find u. That's how you play with these equations. The second equation, v squared minus u squared equal to 2as, also has 4 parameters in it: v, u, a, and s. The third equation, s equal to ut plus half at squared, also has 4 things in it: s, u, t, and a. So in this way, one can play around with the equation to solve any problem. The trick is to select the right equation for a particular numerical. Now, if a ball is being dropped, it does travel in a straight line, and one can say in a plane. In that case, instead of acceleration, we have to use either plus g or minus g. If a ball is being dropped from top to bottom, the velocity at the bottom will be maximum, so we use plus g to find the v at the bottom. If a ball is being thrown upwards, we use minus g instead of a to find the velocity at the top of its throw. The velocity at the top of the throw is 0. I hope this was useful as an introductory video. Thanks and have a great day.